Hi, my name's Steven and I'm a recent bootcamp grad. Since graduating bootcamp, I've been practicing my knowledge with algorithms and data structures so I can prepare for coding challenges. And I want to talk about something I learned yesterday and today. You see, I really like watching YouTube content creators like Tom Scott and Vsauce. They make a lot of educational and in-depth videos that are always really interesting. And yesterday, I was watching two videos that both sparked a thought of mine. Let me show you. Let's start with Tom Scott. I was watching this video of why the prime meridian isn't at 0 degrees.
I am in Greenwich and I am standing on the prime meridian, 0 degrees of longitude. This foot is in the eastern hemisphere, that foot is in the western.
This was a really interesting video about how the prime meridian is considered slightly different for most countries, but what was weird to me is his background, where he's at, where the prime meridian's at. If you look closely, it is where my Zoom background is, and it's a Zoom background I typically use, and it's also a photo of me at this location as my profile picture for every social media, and I thought that was a weird little coincidence. But then the next video I watched was about Vsauce, and he was talking about Morse code. Let me show you that. Right here.
A palindrome is a word that is spelled the same backwards and forwards, like the word race car.
Now, this isn't something that I learned while watching this video. In fact, it's something that I recently learned. Well, I didn't recently learn what a palindrome is, but I recently wrote a blog post about an algorithm where you have to solve a palindrome. Let me show you. Exit out of this one. It's actually right under the Zoom control. Here we are. 2 parts of solving an algorithm. And as you can see, a little bit down, I explained what a palindrome is, and I even used the same word race car. And I thought it was a really weird coincidence too. Turns out it's called the Baader Meinhof phenomenon. It's when you learn about something and then you start to see that thing shown back to you over and over again. But anyways, I kept watching the video. And let me pull that one back up again. If we skip ahead a little bit, he starts talking about devices that help you understand or learn Morse code. So let me just show you that part.
Each letter looks or sounds like in Morse code. But today, I want to show you some mnemonics. Using these works really well. It won't make you fast at Morse code, but it has helped me remember what each letter is in Morse code. Let's begin with this fantastic flowchart looking thing. Here's how the chart works. You start where it says start. A movement to the left represents a short duration signal, a dot. Any movement to the right represents a long duration signal, a dash.
So as you can see, if you're watching this video, you probably know me through LinkedIn, which means you probably know that I am in software development, and you probably are in some way as well. And you probably know as well as I do looking at this, this is not just some flowchart looking thing. This is a binary tree. And what's so interesting about this binary tree is it shows you what every letter is in Morse code by traversing it. If you go to the left, you're adding a dot. If you go to the right, you're adding a dash. And so that means, I realized that if I were to implement this binary tree, I could define a function that decodes Morse code. And I'm sure if this tree exists, somebody's already done this. This is probably already done on the internet many times, and I could just look it up. But what's the fun in that? I wanted to do it myself and just be oblivious to the current iterations that may or may not exist, but surely do. So let me show you what I did. I just pull up my VS Code now, which is right here. So I defined a node class, and then I defined a binary tree, and then I went ahead and I used the video as my reference, and I implemented that graph, putting all the values in the same place listed in the Vsauce video. And then I defined my function decode. And what decode does is it takes in a string that's a Morse code message. It then splits it apart by words. Typically, when Morse code is written out, the spacing between words can be denoted as a space slash space. And so that's what I use to split it. I then defined a message variable and set it to an empty string, and that's what I'm going to return at the end as my message. I then iterate through my array of Morse code words. I then split the words by letters, and letters are spaced apart in Morse code as just one space. and then define my decoded variable, which I will then fill with each word and then add that to the message. I then iterate through the individual characters of each word, and then I iterate through every single symbol that makes up every character. And at the beginning of each one of those iterations, I grab the root node. So when I look at a single character and I go through all the dots and dashes that make it up, I use that as my directions for traversing from the root. So I know that if it's a dash, I move one node to the right, and if it's a dot, I move one node to the left. And by the time I've finished looping through all the symbols that make up that one character, I know the value of that node is going to be my character. So I can add that node to my decoded word. And once I've added all of the letters, I can add that word to my message along with a space. Once I've finished all of that, I can return the message. And so that means when I run tree.decode this long Morse code message, it will return what the word is. I built a Morse code decoder. I just wanted to share that today. I thought it was so fun to just have this Baader Meinhof phenomenon where I'm like, oh, I just, wrote about palindromes. I just am learning about trees and practicing with trees. And then all of a sudden this is just shown to me in a completely unrelated way. And I know I can do something with this. But yeah, thank you so much for watching. I hope you found it interesting too.